In this question, we should take note of each and every detail which we are given. We've been told that we've got a circular disc, which is of radius 5, right? So we just come and draw our circle. This is my circle. And we've been given that the radius is 5. So with this radius, I know that the radius is 5, is called 5, which means that this point, this will be 5, this will be negative 5, and this will be negative 5, and this one will be 5. So this is where we start off. So the question proceeds and it tells us that we've got square bases, right? So these are my square bases, and I've been told that the base of the cross sections is perpendicular to the circular disc. So this will be my circular disc, and I'll have them perpendicular here, and you can see that this is 90 degrees. They're really perpendicular. So I have many of these. So I have an idea that basically half of my shape will be made up of this, and this other half will be made out of this, and my it will be stretching from negative 5 to 5. So what I'm supposed to do, we're supposed to find first the area, the volume of each one of these, then add the volumes of all of these, so that we can come up with the total volume of the whole solid. Okay, we need to find the relationship between our x and our y, and we know the distance formula is equal to y minus b squared plus x minus a squared is equal to r squared. In this case, I'll choose our center, our a semicolon b is equivalent to 0 semicolon 0, and our radius is equivalent to 5. So substituting this, we get x squared plus y squared is equivalent to 5 squared, which is equal to x squared plus y squared is equal to 25. In order to calculate the volume of this whole solid, we know that the volume of any solid, considering maybe this simple case of a cylinder, volume is equivalent to cross-sectional area times height. So in this case, our cross-sectional area is this one, which is length times width, the area of this square. A is equal to length times width. And using this radius, using this equation of the circle, we know that you can find the value of y, this value of y, at a particular value of x, and this value of y here will be equal to half the length. It will be equal to half the length of the base. So in total, the length of the base will be equivalent to 2y. This is the length of the base. Adding this one to this one, we get 2y. Cut. Our volume is equal to cross-sectional area times height. Speaking of which, our cross-sectional area is equal to length times width. Our cross-sectional area is equal to length times width. Our length is equal to 2y. We know that length is equal to width, which is equal to 2y again. So our cross-sectional area here will be 2y times 2y, which is equal to 4y squared. To sum this using the summation, to say limit as n approaches infinity from the summation from I is equal to 1 to I to n of 4yi squared times tangent x. So this leads us directly to the integral sign. We'll get volumetric is equal to the integral from negative 5, this negative 5, up to 5 of 4y squared dx. But we realize that this is symmetrical, so you can just say 2 times the volume starting from here, starting from 0 up to 5, which is equal to 2 times integral from 0 up to 5 of 4y squared dx. And from this relationship, which were given by the distance formula, note that our x squared plus y squared is equal to 25. Therefore, y squared is equal to 25 minus x squared. We get 2 times integral from 0 to 5 of 4 bracket 25 minus x squared dx, which is equal to taking out our 4, we get 8 times integral from 0 to 5, 25 minus x squared dx. Then integrating this, we get 8 times 25x minus x cubed over 3, 5, 0, which is called 8 times 5 times 25 minus 5 cubed all over 3 minus 0, because substituting 0 inside here, you get 0 here and 0 here. Therefore, punching into our calculator, the answer which we get is equal to 2000 over 3 units cubed, since this is volume. That was for the first section. We had squares, but right now we'll be having isosceles rectangle triangles. So we'll just go back to these squares, right? So we realize that cutting the squares at the diagonals, we'll get this isosceles triangle, because this is a square. This length will be equivalent to this length, and this one will be the hypotenuse. So basically we have an isosceles triangle. So now this is what I have. This is what we have now with our hypotenuse at the base here. So basically we have this makeup now. So coming back, we still have the same distance formula. X squared plus y squared is equal to 25. Now the key thing is to find the cross-sectional area, since we said our volume is called cross-sectional area times h. Our h, we still know that our h should be equal. Our h, which is the thickness, is equal for all our triangles. So the key thing is to find our cross-sectional area. In this case we have triangles, so we'll be using the equation half times base times height. Therefore we need to find the height and the base, and we need to find them we have to find them in terms of y. Cut it. At a particular value of x, we get this value of y, which will be half of our hypotenuse, of this hypotenuse. So our hypotenuse, basically our h, I'll name this the hypotenuse, representing this will be our hypotenuse, this will be our adjacent, this side, and this will be our opposite. And you know that this one will be 45. So this angle, the angle produced by our particular shape, will be 90 degrees here. I'll just say this is my shape, and this one will be 90 degrees. So since this one is 90 degrees, this is an isosceles triangle. In order to get these angles, we say 180 minus 90, then divided by 2, we get the angles of each, and what you get here is 45 degrees for each of these. So we know that this length is equal to 2y. Our hypotenuse is equal to 2y, and this is a right angle triangle. Therefore we can use in order to find any one of these sides, since any one of these two are equal, we can find any one of these, and we know that by finding any one of these we have the base, which is this one, and the height. So using this angle to find this adjacent, and to have this hypotenuse. Using this angle, the adjacent and the hypotenuse, you can actually use the cosine rule, where you have cos 45 degrees. This 45 degrees is equal to adjacent over the hypotenuse. Speaking of which, our hypotenuse is equal to 2y, adjacent over 2y of cos 45 degrees. Therefore our adjacent is equal to 2y, so adjacent 2y times cos of 45. Cos of 45 degrees is equal to square root of 2 over 2 times 2y, which is equal to root of 2y. And our adjacent is equal to the opposite, and the adjacent, which is equal to the length, which is equal to, I'll say, the base, the half of base, which is equal to the base, which is equal to the height. I'll just say this is my base and this is my height. Therefore just substituting in these into my formula, you get area, cross-sectional area is equal to half of root 2 y times root 2 y. This will give us a 2, so get half times 2 y squared. So this will cancel, then we get y squared for the cross-sectional area. Going back to our formula for the volume, that volume is equal to cross-sectional area times height. Our height is equal to change in x, and our cross-sectional area is equal to y squared. Therefore, here volume is equal to y squared times change in x. But this volume will be the volume of any one of these, which will be y1 squared. Obviously, this is v1. But we need the sum of the volumes of each of these in order to get the total volume of the whole solid. So we use the summation again. Volume is equal to the limit, as we have an infinite number of these triangles. Summation from I is equal to 1 to n of yi squared times change in x. Therefore, translating this directly to the integral sign, we get volume is equal to the integral from -5 to 5, -5 up to 5 of y squared times change in times dx. You know that the shape will be symmetrical, so we can multiply, just consider this part and multiply the volume by 2, and to our limits here will be taken from 0 to 5, say 2 times integral from 0 up to 5 of y squared dx. And you know that y squared plus x squared are equal to 25. Therefore, get y squared is equal to 25 minus x squared. Then substituting into our integral sign, get integral from 0 to 5, 25 minus x squared dx, which is equal to 2 times 25 of x minus x cubed all over 3 integral from 5 up to 0. Then get 2 times 25 times 5 minus 5 cubed all over 3, and punching this into the calculator, we get 500 over 3 units cubed, since this is volume again.